So tonight we're going to talk about, I've actually never taught on this particular topic, so this is going to be a new one for me. How information actually points toward God. So let me go ahead and pray for us, and then we'll get started. Heavenly Father, thank you so much for this time together as we come together to look at how the world points toward you. Lord, help us to not only recognize it, but find ways that we can share this information so those that are doubting or have misconceptions can see what's obvious to us and make that decision for you. We pray this in your name, Lord Jesus. Amen. So, information. Does that sound like an exciting topic? So, information actually is pretty exciting if you think about it, because everything in life actually comes to us in the form of information. And I never really thought about it as being an argument for the existence of God until I was actually listening to some people online, and they just mentioned it cursorily. It's like, oh, this is another argument you can talk about. And I dug, and I couldn't find very much out there. So we're going to take a deep dive into three main points on information. But we're going to look at cumulative case. I've been telling you during this class, we want to look at what the atheist says to these same arguments just as much as what we would say as Christians. So we can see how their arguments are formulated, and then the fact that their objections are real. We have to know how to address that if we're going to communicate with people that have those views. So we need to understand where they're coming from. So today, we're going to talk about just really three topics. The intelligibility of data, and why can we actually make sense of the world around us. Then we're going to look a little deeper, and we're going to talk about language and communication and how that it goes beyond the natural to the metaphysical, because how do we actually understand these sequences of sounds and little ink marks that we take for granted as our communication. And then we're going to look even deeper and go into a little bit about DNA. Not so much today, because we're going to be talking about it in a couple weeks when we talk about life, but it fits well with the concept of information. Any questions before we get started? Okay. You guys, don't be quiet today. I'm going to ask you a lot of questions. Third one, I think. No, fourth, maybe. I don't know. I have to look. So this is kind of the flow of our thought process. I've been calling them guardrails because we need to put some boundaries on our conversation so we understand what we're talking about. There's a lot of other things you could talk about, but we want to stay focused within our guardrails so we can kind of get a better idea of what the atheists think versus what we think as Christians. So we're going to focus on what we can observe, the things we can see with our five senses, things that can be measured in some way. And then we're going to use our reasoning skills, and we're going to see what follows logically from that information that we can process from the world around us. And we're going to do what we do every day. We're going to make inferences, and we're going to weigh the probability of options, and we're going to do analogies and look at what the best explanation actually looks like. People say, oh, you shouldn't do that, but everybody does it. Even the scientist does it. It's normal. This is how we reason. So we're going to just follow natural reason, and we're going to test the atheist reason versus essentially the theist reason, the Christian reason. And then based on those reasons, we're going to look at what worldview best accounts for what we see in nature and our ability to process it. That's information systems. We're just going to look at it and weigh it. Obviously, I believe I know which way it leans, but I think we need to be really careful that we look at the strongest arguments against our view. You hear me say this a lot. We don't want to be sensational. We want to be intentional. We want to look at what people say that has convinced them to not believe in God so that we can understand their position in a way that we can potentially help them. And we have to be comfortable with these arguments. So, okay. And I often, I haven't used this term here at the church, but I like the term steel man arguments instead of straw man arguments. A steel man argument is when you look for the very toughest argument against your view, and that's the standard that you work from. Straw man arguments is what most of the world does. They invent an argument that they say you have, and then they knock it over because it's not really your view in the first place, right? We want to always look at the strongest view against our faith because the truth can stand up against anything, okay? So we got to start with vocabulary, and I know you're going to love me for these, so, okay. But we got to, actually, I think it's really important when we start to have a conversation, especially with someone that doesn't have our same worldview, we need to define the words we're going to be using because they can use the exact same words that we are and mean something completely different. And it happens a lot. So we want to define what we're going to say. So data are the physical states that we can see with our senses, or we can devise equipment that can sense them, right? That's data. Information is the pattern that comes out of all those randomness of data, and it reduces the uncertainty, or it carries a specific function. Information is not just data. It's data with purpose, right? And then a mind. We had to define a mind because our atheist friends have trouble with this. A mind is that which can know and can think and can understand, can choose. If you can make a choice, you're discerning information and then making a choice, that action, that's a mind. It doesn't have to be a human mind necessarily to be a mind, okay? Intelligibility. The fact that a message or a pattern or law or the world itself can be understood by our rational mind. There's a difference between a rational mind and just a mind. That's a point I probably should have made. So intelligibility, the word, if you're not familiar with it, just means that you can make sense using your mind of the information that is coming to you, right? And then intelligence is the ability to understand and use knowledge purposefully. That means we can take this information that we can intelligibly understand and then make decisions that go against simple chemistry or physics. We can do things with that information.
Is that wisdom?
Wisdom is another word. Wisdom's probably more philosophy than what we're talking about in here, but yes. Okay, that's enough of that. So this is a rhetorical question. I don't expect you to be able to answer it, but intelligibility data, that's our point. Why? I mean, have you ever really thought about it? Why can we make sense of the world around us? And more importantly, why can only living things make sense of the world around them? I mean, single-cell bacteria can sense things and then make decisions. A rock doesn't seem to be able to do that. I'm not talking about gravity or magnetic fields. I'm talking about being able to make a choice. And we're going to look at the challenges to this, but this is an important premise of the Christian worldview, is that we can perceive these things because God made it that way, right? So we would say that what we do observe is that information is readable, right? I wish I had a copy of my book with me. It might be from a simple-minded person, but it's more complex than just a random combination of words or even letters, right? When we see a sentence or we see a recipe, we know it comes from a source. That's intelligibility. A map that guides you someplace is more than just random ink marks on a page. So that's what we're talking about. So we do not infer it's by accident when we see things that show design. We infer that there's an adequate source or an author, a maker of some sort when we see these things. And if you look around the room, most of the things we see in this room, we can perceive have been made by an intelligent, rational person, right? You know, the tables, the paper, the chairs, everything is a made item, right? And so the inference to the best explanation that the Christian makes is that we can observe these effects, the intelligible information that we have in the world around us. We know what the known causes of designed items are. Rational items usually come from a mind, right? We have no examples in our world that don't come from a rational source. So the best explanation is the things we take for granted, information, data, must have originated from a rational source, i.e. God, right? So this is the same kind of reasoning that we use everywhere in our life. Forensics, archaeology, history. Every time you make a decision, you're using this same flow process. You observe things, you use known processes, and you make the best explanation or the best decision based on that. So that's all we're saying as Christians. So the world can be read. Nature is much more than pure chaos. We think, of course, we know there can be stable patterns like crystals and snowflakes. And mathematics, though, as we learned last week, do an amazing job of mapping the reality that we live in. That is information being processed through a system. Human minds can understand those laws, but they didn't create them. We just discovered them, right? So we can do experiments to test how those laws of nature work, but we don't really know where they came from. Yet we trust them, and we believe that we can reliably discern the information that we're given. Scientists do it every day. But why is the world so ordered in the way that we can actually even do science? So we would say, why is there a match between the rational structure of the world and the rational structure of a human mind? That's the bridge that the Christian says is because there's a creator God, right? So let me go through just a logical statement so you can see what our general perspective would look like in a logic diagram. So meaningful information is routinely produced by rational agents, right? We know that. The universe contains intelligible patterns, laws, and information-bearing signs. Things like gravity, things, we can see colors. Human rationality is capable of reading and testing and using that intelligibility. We can process it. So the theist, Christian, would say it best fits with the grounding in a reality where there's a creator that created those things. So that's our claim. So, okay, what type of challenge do you think they lay at us? Let's just talk about one. This is
string theory, that order arises out of chaos.
White noise,
Yeah.
right? White noise. They will say, you're confusing information with meaning. Is there information in this white noise diagram? Well, there's data for certain, right? A lot of it. They would use an argument like this. They would say, a signal can contain information mathematically without carrying a personal meaning. So they would say, mathematically, I can actually model that white noise pattern behind me, and it has no meaning at all. So why do you think when you see a pattern that you perceive as meaning, why do you think it really is meaning? It's actually not, it's a tough objection. You got to think about it. So, okay, let's look at it. First, we need to focus our boundaries down. Random noise may look like it's rich information. There's a whole bunch of it on the page, right? But in a technical sense, it doesn't have any message. There's no usefulness in this information. It's truly random information, right? So, any thoughts on how you can respond to the atheist?
Well, it's not necessarily that it's not useful. It's not useful to us, right? But it may have meaning like in a greater context. Like the white noise itself is showing that there's signal interference. So it has a meaning in that sense, right?
Hmm.
It may not have like a meaning in terms of every single one of those pixels directly applies to us, but it does apply in a greater sense to something.
Potentially. I mean, yes, fundamentally. But it's really tough for us as rational beings to make sense of this. So it would qualify as data instead of information because it's not in a situation where we can discern the meaning of that information. Remember our definition at the beginning.
Yeah, but it's that same statement. So like the definition for data in statistics, right, that we use is that it's observations, right? And information is going to be the patterns that we can glean from those observations.
Right.
But just because we can't glean the patterns doesn't mean that they don't exist.
But
It doesn't mean that there's not something that's intelligent.
well, you can say that about anything, but the defining factor is if you do not know of one, then to you there is no information there. And in this case, it actually is us. We're the intelligible being that's processing this. If someone else can come up with a meaning of that, good for them. But when I'm talking to somebody, unless I can come up with that, we're both on the same boat, and we start with the fact that randomness effectively is not real information. It's data, though. Information has to be processable, and that's what we should talk about. We need to distinguish between things like Shannon noise, which is random noise, and functional information. If it's not functional, then we're talking about semantics. And that's a really classic argument that you'll see from the atheist, is they're going to play games with the meaning of words and how we're using them to try to find a loophole in the argument. So we don't want to build our argument in ambiguity. We want to be very specific what we're talking about. And what we're talking about is functional information. And to us, in the conversation we're having, white noise would not be functional information, even though it probably provides something. You can have hidden messages. I don't know it, so to me there's no information that I can discern. Right, next one. Natural processes can produce order. It's true. Snowflakes, crystalline structures, they follow physics. So the objection that the atheist would use would be something like, matter can self-organize under natural laws, therefore order by itself does not prove a mind. What do we do with that?
Go talk to somebody else.
Just agree with them. It's true. Snowflakes are formed by physics. We know that. Crystals are. Sometimes we don't argue at their standard. We stay with what our principle is, right? The argument is not about order. I never even used that word when I was describing an argument earlier. The key question is whether that pattern is interpretable. Does it have meaning? And basically, is it directed by a rational being? You had a question? No, okay. So the key is whether or not the information has a function. I don't have a function for the snowflake other than it's pretty, right? So again, this is a classic method that I've seen with the atheists is they're trying to twist the argument so that there's essentially a way out of the argument. Don't let them do that. Stick with the point. We were talking about functional information. All right, so the next one they're going to go to is always going to be God of the gaps, right? That's the big hitter that they always use on us is this is just a God of the gaps argument. You're saying science can't explain it yet. So you're just saying God must have done it. And sadly, this is always where they go. So what do you do?
Ask them why they're treating science as if it's God, because science is
This is really good.
Science is our current understanding. That's literally where the word science comes from. So you're saying that science explains something. We may not have recognized the patterns yet, but that goes back to what I was saying before. Like, just because we don't see the pattern doesn't mean that the pattern doesn't exist.
See,
right? And God is meant to be like our idea of order as Christians, right? It's like all truth, all knowledge comes from God. Wisdom comes from God. So that means that's where the patterns come from.
yeah, so
right?
this is an opportunity to be snarky. You know, I like being snarky once in a while. I would say, don't argue with me out of ignorance. That's really what they're claiming. They're claiming ignorance. Okay, they're claiming, no, science doesn't know it yet. That means you don't know anything. I have an explanation. You have nothing. When they use God of the gaps against a Christian should just step into it and say, what do you put in the gap? Ignorance is not an excuse. What's the best explanation? Remember, that was our premise when we started. Is the best explanation an explanation or no explanation? Well, by default, an explanation is always going to be better than nothing. All right? Maybe mind is a late product of matter. They're talking evolution, obviously, here. And they'll say something like, brains developed and the language emerged, and the meaning is a human projection onto the otherwise non-personal universe. Richard Dawkins, a famous atheist, would say it this way. So how do we deal with this? This is all this stuff you think is evolution, right?
Like you said, how does a single cell organism respond to patterns then? If this is just a late development of matter, it's like we recognize that these things can respond to patterns that they learn from, right? Like slime mold. Slime mold can learn how to go and solve a maze based off of the rewards that it's able to reach along the way, right? So it's like I don't find that to be a valid argument. To say, well, it just came about because of the mind. It's like these patterns themselves naturally coalesce, right? Like you said, we see the snowflakes that go and naturally form along a certain pattern.
Right.
Those patterns themselves are useful in that they allow, like in the case of snowflakes, them to be able to interlock and be able to create structures, right? So it's like if it was just random patterns, then we wouldn't see this usefulness.
So I think you should always look at the words they use. Now, I should have put random on this, but I was trying to be as powerful an argument as possible, because randomness actually unzips their argument pretty bad. But they talk about developing, emerging, meaning, a projection, non-personal universe, right? So basically saying nothing has any meaning. So I think we should take that and say, okay, effectively what I'm saying here is if you think reason came about by random, non-personal means, then why do you trust it? I trust it because I trust the source. If it came by blind, non-rational forces, why are you trusting it? And why are you even trying to use it against me? Because the atheist cannot believe in reason and logic because there's no foundation for it. If they think it's a development of human culture. So can a non-rational origins fully ground rational trust? The concept is, why would you trust something that came about randomly as trustworthy and repeatable? It's random. It shouldn't be repeatable, right? But they're always going to use our worldview to justify the process they're using to challenge our worldview. You always got to see that, and then they just point it out. It's like, what is your basis for trusting reason? And typically that's the end of that conversation. What about confusion, error, and disorder? Now, this is a good argument. Why do you think it's God when the reality comes from a rational God? That's what you're claiming. If it really does, then why is there so much ambiguity, suffering, mental confusion, false belief, and disagreements in the world? Go right to the character of God. That's what they want to challenge. They always do. It's a sequence that's predictable. So they're challenging the character of our God. How should you address it?
You don't know what God is.
Yeah, I would just step right into it and say, that's exactly the world that the Bible predicts. That's exactly the world. Only the Christian worldview actually predicts the way the world is. It's fallen. It's broken. It's not the design. We're comparing to a design. Remember, we have to have a standard for comparison. How do we know all those things are a problem unless there's a standard that we're comparing it to? Naturalism has no standard. How could they possibly say things are confusing compared to what?
They see it as broken, don't they?
Everybody sees the world as broken. That's the reason they always complain about all these moral issues when they have no grounding for their moral issues.
Well, how do they know it's broken when there's no comparison if it's not broken?
It's really the same argument we use in the moral argument, because it always comes back to, if you're going to make conclusions, you have to have a standard for comparison. If not, it's just randomness. Why do you care? Why are you even bothered and talk to me? The fact they're engaging with me already proves they don't believe their worldview.
Yeah, I mean, we look at it as Christians, the world's broken because of fall of man.
Yep.
I mean, that's the answer. They don't accept it. But
Nope.
They don't see it.
No, because they don't want to see it. Yet they're using that fallenness as their standard for comparison. But they also have to know there's something better than what we live in. But so you've got to always remember the atheist is actually this close to being right. It's desire that they lack in most cases. They desire there to be no God, so they frantically look for an excuse to ignore.
They want to be their own God.
They want to be their own God, their own standard, right?
Yeah.
So it really comes down to this when we talk about the intelligibility argument. Theism says there's a rational foundation beneath reason, right? Meaning, truth, the order of nature. It all comes from a source that is all those things. The materialist, well, they don't really have a basis, right? They can't explain where rational thought comes from. Why do we trust rational thought? Where does meaning come from? How can you have meaning if you have no basis? So we should always put pressure on them to come up with a basis. And generally, they're going to use our worldview to do that. And that's when we should push that conversation. So where in your worldview do you have this basis? It doesn't exist. The only way to process the intelligibility of the world is really based on a belief in God, that you have a standard that you can do it with. Now, it doesn't prove God. It doesn't. But it supports our theist view. And like I said, the cumulative case is the way to approach these things. You had something you want to say?
Yeah, one of the ideas that C.S. Lewis brings is he was observing two little boys playing. And one little boy said to the other one, "That's not fair. You did something wrong." Now, the question he had come into his mind, who was he appealing to? I mean, he's a little kid.
Yep.
But there's a sense of fairness and order, and something's right and something's wrong.
Yeah, especially when it's happening to you.
An atheist doesn't want to see that, does it?
You know, you see that in the atheists. They will talk about, oh, there's no meaning, there's no purpose, and then someone steals something from them, they call the police. I mean, why? If there's no meaning in anything, why do you think you deserve anything different? Like I said, worldview is really important. I always keep coming back to it because we want to make sure that they're going to make claims. They're making it from their worldview. Don't let them use yours. Because that bridge between the two worldviews is really how we get them to pay attention and hopefully recognize that there's a gap in their thinking.
Next, what you were talking about last time with beauty, right? It's like as human beings, we like symmetry because that's what we typically are talking about whenever we're talking about beauty. You know, like the foundations of traditional beauty is a symmetrical face, right? And so it's the same thing as human beings, or as thinking, reasoning beings. We like symmetry. We like patterns that are intelligible. And then that goes back to what you were talking about with the whole, who are they appealing to, right? Yeah. It's like, well, we're appealing to this idea that things are meant to be symmetrical, right?
Yeah.
And but like you're saying, well, why would they? If we only arise from chaos, then that should be the natural order that we're all used to.
That should be your standard, right?
That should be the thing that we're all looking towards to be like, well, no, everything's just chaotic. But nobody's looking at things like that. Everybody looks at things saying, hey, there has to be patterns, right? We know that whenever we see clouds showing up that are getting dark, hey, it's probably going to rain soon. Or if we feel a drop in the air pressure, oh, rain's coming within the next hour.
We're always trying to make sense, functional sense of the information that's coming in. Right. If it's not functional, we tend to ignore it. All right, let's take a step down the functional path and talk about language. That's information on steroids, basically, right? And there's different kinds of languages, right? Hieroglyphics, written language, that's Greek. Computer code, those are all languages. So what we need to define some terms before we start the conversation. I know it's boring, but let's talk with code. Code is a mapping rule between symbols and outcome. That's all it is. Code just means I have a way I know an A is an A, right? I know a B is a B. Every language has something like that. And language is a mind-to-mind communication system. Whether it's spoken or written, it can be signs, it can be gestures, it can be colors and lights. It's some way of conveying a message through some sort of a code, right? That's really what language is.
Like the Chinese have ideographic language.
Yeah.
It's all about symbols and what they mean.
Yep.
We don't think that way.
No, but visual, which is written language, spoken, it can be heard.
Well, we do now, because if you look at emojis, right? That's like ideographs that younger people use. True, that's true.
You know, I don't know what most of those mean. It confuses me. I know thumbs up.
Even look at the meaning of rises, right? Because
Yep.
something like a good one is the chocolate ice cream emoji. A lot of people think that it's something else, right? But it initially started out to mean chocolate ice cream.
Yes, now
Because
it's,
the image now it represents
yes.
a totally different thing. But it's the same thing that we get like whenever you look at symbols, right? We ascribe the meaning to it because we all agree based off of it, right? That's where we get that meaning, like A being an A.
Yep.
It's because like over a wide range or a wide geographic range, people went and said, hey, this upside down triangle has this off sound. It looks like, something that would,
Right.
We were doing a thing at College of Biblical Studies, and we had Dr. Colley in there, and he was doing his doctorate, and he was going into analyzing the different Wycliffe translators and all the things they were having to go to translate these various languages. And he would bring people in from different countries and show us what they were doing. And one came in, and what he was trying to develop a printed written language for was to correspond with a language that was actually whistling. The whole tribe,
The language was whistling. Some languages are clicks, and so these are oral languages, and Wycliffe goes in and tries to generate a written language to go along with that.
They had the guy that he came to speak to us and showed us where he started and where he was ending up.
Yeah.
But the fact that it was doable.
That's way beyond what we're talking about today.
In Spain, they actually have a language like that, though. It's a whistled language. It's in this mountainous region. They said even the goats can understand it. It's like that. But it's because they have basic commands that are done according to the whistles that the goats have.
Let me get us back on target because we're going to be here a long time. I'm already 10 minutes behind my schedule. So, argument of language. Does meaning point beyond matter to a mind? Go ahead, Jeff.
Well, I was just kind of thinking antediluvian language. We had no idea what the ancients thought after the flood, other than what we know from Noah and his family. But the land is littered with antediluvian symbols, the pyramids, the Sphinx, and you could argue a lot of great mounds here in the United States that we have that are thought to be pre-flood. We've learned sort of things about their language, or the caves, the Egyptians in caves and stuff.
Well, I mean, we don't know if there was written language. We believe there are pictorial languages before the flood, but the first written languages appears to have come out of Egypt. I personally, as a Christian, believe Joseph is the source of that. I think archaeology supports that. That's Hebrew 1.0, but the pictorial languages go back potentially to Samaria, right? So, and that's what we're really talking about. We're talking about, does language have to come from a mind? I think it's obvious that it does, but this isn't something that atheists are going to challenge because they have to, because I'm heading toward DNA and they know it. And if they concede any one of these points, they're going to drown when we get to life itself.
Even animals have languages, right? Like we think of language as being written down or like a communicatable, right? But it's like animals use body language and their own calls in order to be able to, give logical commands to one another. Say like, food is here.
Well, that's the reason I said mind, not necessarily human mind. Language can come from any rational being, right? You know, my dog can sometimes be rational.
It's a representation of logic, though. It's a representation of recognized patterns, right?
But let's talk more written language for our purposes than spoken. Spoken's a little more complicated but written languages are ink marks that have meaning that are processed by mind. So language is just not noise, it's noise plus something, right? Animals can have language, but written language is pretty unique to humans. It's okay. First pro argument, that's from the Christian. Meaning points to a mind. Language carries intentional meaning. Meaning comes from personal agents. The world is full of meaning, so that fits best with a personal creator. It's a pretty good argument. Well, a counter to that might be something like this. Natural orders can explain language. Human brains and bodies are built for it. We have lungs that can make the sounds. We have all the right anatomy. And if I'm injured in some way, I can lose my ability to speak. So it looks like it's tied to the biology. And then social constructs. Language develops over time. We know that. Our own language develops over time, like slang, and words change their meaning or they disappear from our vernacular. So there is a natural account. They don't deny there's meaning in those symbols. They just deny that there is a source beyond just simple evolution. Pretty good challenge. What do you do with that? Our premise, their premise. You guys are so quiet. This is tough. Agree with them. We got to learn that when it doesn't really impact anything, just agree. It's a combination of physical and mental. Our argument is where that mental comes from, not that we have physical attributes that we can actually do it. You'll see this with the atheist arguments. They're trying to distract you from your point. Our point was about a mind. Their point was about social constructs and biology. We don't deny any of those things. Don't let them distract you. Or they'll try this one. Well, okay, I'll do another pro. This one's fun. Grammar, my least favorite thing in school, grammar. Grammar reveals ordered rationality. The idea with grammar is that you take this finite pool of characters, we call it like an alphabet, we put it together with certain rules, and we can develop really unlimited expressions. With just the 26 letters in our alphabet, we can do amazing things. Just with a 0 and 1 in computer code, it's almost limitless type of expressions we can come up with. So we believe that's pointing to the mind. And a mind has to come from someplace that's rational, right? So we would form it like this. Language has structure, not just signals. Reason and language fit together. And rational logos, or God, explains where rational creatures come from. Because they can't get to the rational part. They think we're just random chemical and physics. We're going to hammer rationality throughout this conversation. Okay? Well, here's one of their counterclaims. Language looks messy, not engineered. If it came from God, it should look less messy, right? Languages are historical. They contain irregularities and ambiguity. I can't say it. Ambiguity. Is that close? Yeah, thank you. Messiness may fit culture better than it does design. Okay. So, what do you do with this one?
Well, I'd ask them which languages they're looking at.
No, Dana got it. Just agree with them. Human messiness degrades design. We call it the fallen world. This is exactly what we'd expect in the worldview. They believe in evolution. Doesn't it mean things should be improving? I mean, that's what evolution actually means. Our worldview actually matches this better than theirs. Don't be afraid to agree is kind of the moral of the story today. Okay, another pro argument. The world is remarkably speakable, means we can process what we see with our senses, right? So we would put together an argument that looks like this. Language maps reality really well. We can talk about the beautiful sunset or the food we just had, right? And truth assumes some sort of correspondence, right? We believe that we can convey this reality truthfully, right? So the revelation completes what reason begins. So the fact that we can map reality with our language has to start in a reality we can actually comprehend, which starts with a rational being and a mind, right? Come right back to the ration. So, okay, let's look at their challenge. Meaning may come from use instead of God, right? So don't confuse language requires a mind with language proves God. So they'll say, yeah, of course, language requires minds. So now they're going to hedge a little bit. They're going to accept that a mind is necessary, but that doesn't prove God. It doesn't disprove God either. Right on. So let me build a logical argument first, though. So meaning is learned in human practices is what they would claim. That's culture. Language works without proving metaphysics. I don't need to have any of this great spiritual stuff to understand language. God is an inference that is not needed, is what they would say. So now they're saying, yeah, okay, the mind. I have to step closer to you because I can't argue against the mind anymore. And it proves influence of culture, but not the how and why. So we'd accept what they're saying. It's like true. We know culture affects language. We have plenty of evidence in it. But you haven't answered how and why we can even have that language, how we can process what's there. They've taken that step toward us. They've accepted that we have a mind. Now they're in a back pedal mode. So it comes down to, again, our cumulative case. You look at those arguments, and what is the best worldview explanation of the information? If you loaded up all those arguments that we just went through, and those are the best ones I could find on both sides, which side actually has explanation for what it is that we actually see? The theist has an explanation. They call it God of gaps. We call it God of the answers, right? But they'll have to, at some point, relinquish the idea that a mind is just impersonal chemistry, because then there's no ration, and then they can't argue with you. So you see how this sequence kind of tumbles? Okay, let's look at the last one, which is DNA code. I don't know how much of this we'll get through. So we'll talk about complexity, and that DNA data kind of looks like it's compressed and encrypted, and then we'll try to look at some arguments of alternates to a design model. But let me get a couple of definitions before we go any further. Encryption, in our world, you'll argue with me on this one. Just trust my definition for now. Encryption, encoded to hide from unauthorized readers. That's a really weak definition, but that's how we're going to define it, okay? Basically, encryption doesn't allow people to randomly access things, right? And compression is efficiency in the way the data is represented. Less redundancy. So if I can reuse letters, then I have a little bit of compression, right? I know you guys probably don't like biology and genetics. I do, but I'll go through this kind of cursorily to be quick. Our DNA is made up of 4 bases. We represent them with A, T, C, and G. Do you really want to know what they are? Adenine, thymine, cytosine, and guanine are what the actual nucleotides actually are. And they're very complex molecules. These are organic polymers, essentially. And the sequence makes a big difference in the information that comes out. So we know the sequence is, the outcome from that information is sequence dependent. That's just like a language is. And it's incredibly complex. It has things built into it that can repair damage. It can identify problems. They have bits and pieces within our DNA that allow our bodies to actually read the DNA. And our DNA, the humans, is like 3 billion characters long. And it's a binary chain, so it's actually twice that long. So it's a tremendous amount of information. And we call it information because it actually translates to functional use, right? So, okay, let's get a little further down this. So, as a Christian, we would look at it and say DNA effectively translates to proteins. That's the simplest way to understand how living things work. DNA is the stored information that is copied into RNA, which is the working copy that goes to a ribosome, which creates a protein based on that information. So this is sequence. It's a very elaborate system, and there are a lot more that goes into it. So biology uses chemistry to move from sequence to function. So as a Christian, that's our claim. It's beyond biology when you go from sequence to function. We know in the rest of the world, everything we observe, when you go from sequence to function, it requires intelligence, right? So genetic code includes what they call codons, which is 3 characters at a time. It's actually how DNA is so magical. It has all these built-in protections from misreading. And this is just a sequence that shows a particular amino acid formation. I'm not going to go into it in detail, but it follows a rule, a mapping rule. Remember we talked about mapping rules before. And then that mapping rule takes the physical, the mapping rule becomes physical because of what the RNA and the ribosome does. It actually produces an actual biological compound. And it's more than just biological. It can actually be transferred. It can be inherited. And in fact, DNA is not the only information in our cell. You guys probably didn't know this. You know the membrane in every one of your billion plus cells, there's not anything in the DNA for a membrane. It requires a membrane to copy to start with. We can't even make them in a lab. DNA, as far as we know, nothing to do with membranes. That's just a bonus. Okay, so let's talk about why we think DNA is like a language. A recipe, ordered symbols, it's a good meal, right? A blueprint gives us specifications to build a building. Software code gives us specific output so I can run my computer, so I can project this on the screen. The genome looks very similar. It's a sequence that generates a function. It's a biological function instead of an electronic function, but very, very similar. So the key is not mere complexity, it's the fact that there's functional specification in the DNA itself. So as Christians, we embrace the science. So our argument would be that the sequence is dependent on the function. The same chemistry arranged differently can produce different biological outcomes. That makes the sequence not just substance, but central to life itself. And it's actually true. I talk about James Tour from here, down here at Rice, and he talks about each one of these biological proteins have all kinds of different shapes, exact same molecules in exact same order. If they bend and twist in a different shape, they can be toxic to the human body. We can't reproduce it outside of the living cells. What we reproduce tends to be a very small percentage of what we actually need. Everything else is toxic to us. Our biology seems to understand that. The rate at which it builds things, the amount at which it builds, all controls that shape, which is so critical. It's not just the chemical compound as much as it is that additional information that it actually gets from our DNA.
Like Down syndrome?
Down syndrome is a degradation of genetic information. It's not, we'll talk a little, well, we're not going to talk specifically, but diseases generally come from degraded genetic material. It's not new information. So, I have degraded DNA too, right? So all of us do, because Adam had pure DNA and the rest of us are all a bad copy. Yeah. So, okay. Counter argument. information is not automatically mined. So they're going to challenge this, and they'll come back and they'll give us some random Shannon sequence. A Shannon sequence is just random information. Say, unpredictable but not necessarily meaningful. A lot of atheists think that our DNA has a lot of junk in it. And we'll talk about that a little bit more. But functional information, a sequence that reliably contributes to biological task or to life itself, is very different than meaningless jumbled information. Okay, they're always wanting to compare the two. Don't allow them. What would you say to them? Yeah, make sure we're using the same definitions. That's the reason we define our terms at the beginning. They're always going to move toward randomness if they can allow push the conversation that way. Just don't allow them. Stick with the defined parameters. That's the reason we did it right at the beginning. You should always do it when you're having one of these conversations. Another challenge would be natural processes generate new information. You guys heard that? I've heard that. But our kids even heard that in biology class. Duplication can copy a gene. There's mutation to alter sequences. You have recombination issues that can reshuffle the material. And then that changed sequence can be preserved. How do you challenge this? It's a lie. Science doesn't support it. Less is not the same as new. We've got to remember all these things that they're talking about are degradation of the genetic information. They're not improvements. In fact, I'll make fun of my dad because he has blue eyes. You know the difference between brown and blue eyes? It's a loss of genetic information. Right? The people that have colored eyes don't have the genetic information for the color that makes our eyes brown. I have just as much blue as my father. My eyes look brown. Those are changes to the genetic code. It's not new function, though. Diseases come from degradation, mutation. I have several friends that have done genetics for their entire working career, going on 40 plus years, some of them, and they induce mutations, one on fruit flies and another on bacteria. And they've generated millions and millions of mutations over this time. You know how many functional new traits they've generated in all that time? Zero. And go ahead.
So the RNA COVID vaccination, is that a genetic thing that they're trying to break down into
Viruses typically are RNA.
Yeah.
That's what they're made up of. They're not as complex.
They're trying to address how the virus attaches to the cell. That's a totally big, different conversation.
Well, I saw you brought RNA
But,
up.
but
it's like,
the vaccine is attempting to try to block a receptor for that virus in our cells, and that's the
but it's
reason.
going into the
Yeah,
farm.
it's not putting new DNA in you.
No, but they're trying to figure out a way.
Those are mRNA though. The vaccines that they were doing for COVID were mRNA. The M means modified. So they tried to change
Messenger.
Yeah, or they tried to change the way that the genetic material inside
Right,
the virus
that's why they
was.
screwed it all up.
But yeah, what ended up was it didn't allow us to build up the immunity that we would need to the actual virus itself.
That's why it's
It's
all
not the
screwed up.
Yeah. I mean, their rationale made sense in a laboratory, but not in function. It's how I would describe it. But that's not. We're really talking about tRNA, which is a transcription of our DNA that goes to the ribosome to make proteins. Messenger RNAs get sent to other places in the cell to do different things, and that's where the vaccine was trying to inject itself into the living metabolism. Okay. But whenever they say new information, and you'll hear this, you'll read it in biological textbooks, ask them to give you one example. One example. They won't find one because there are none. I read about them all the time, and then you look at the fine print, and it's like, this is a removal of a trait, not an additional new trait. I'll talk about it in a couple weeks when we talk about life. Okay. I'm going to run a little late, sorry. Code-like mapping. We talk about it as a Christian, that the codon idea, the idea that our DNA is read in sets of 3, and then it's translated to the tRNA and then the ribosome, and then there's an outcome of a protein or an amino acid or some biological polymer. These symbols map with rules to a functional output, meaning the symbols we use over and over and over again, but there's a rule that applies to those sequences that results in a specific outcome. Now that's a very elaborate informational system, and that's working within our cells. In fact, we can't reproduce its accuracy. I think we'll get to this later. Let's see. So that's one of our claims, is it's so complex. Function from code.
Is it like a language?
It is like a language.
It's real high end.
It's a chemical language. It's more sophisticated than our language. There's only 4 characters, yet, everything, all living organisms come from those same 4 characters.
We believe that is a language that it has rules and
Yeah, I mean, a language might be going too far. It's definitely code, because it's code for function.
It conveys order.
It conveys order.
Right, because it's showing a pattern that can be intelligible. It's the same thing with quarks, not with quarks, with protons, neutrons, and electrons. Really, if you think about it, like they have an order, right? We know that they have a specific pattern that they hold on to, and whenever they go into these specific patterns, that's where we get different kinds of atoms, right? It's like if we see a neutron, right, and we see a electron that's going around it, then we know that that's going to be hydrogen, right? Because it's that specific order.
In theory. The physics is getting more complicated the more they learn. We'll talk about that when I do astrophysics in a couple weeks. Genetic code, this is a con, this is an atheist talking. Genetic code origin is under active research. This is the last bastion of argument. Oh, we just haven't figured it out yet. It's active research, and then they'll talk about all these different things. My favorite is, did the code grow with metabolic pathways? Does the code reduce harm to mutations? Those are questions that research is trying to determine. What do you say to this? Be snarky. If your atheist says, well, see, you're just making a mountain out of a molehill. Well, I would just say, those are all hypothetical claims. Yeah, well, it's like an argument of ignorance. And I mean that kindly to my atheist friends. You don't know is not a better explanation than I know. Okay, it's just not. No matter how much you want it to be, the best explanation is the one that actually exists.
Yeah, because I'm better off. If you have at least an explanation, you don't.
Okay.
Okay.
I want to skip. There's several of these. They're in your notes. I'm going to skip forward a couple to try to get to the end. Or unless you guys want to stay an extra 15 minutes and go through them all.
Keep going.
Okay, we'll keep going. All right. Density and storage. This is kind of amazing. Our DNA is overlaid sequences that make different proteins depending on where it starts and stops the reading or the transcription process. So the same stretch of DNA can produce multiple different proteins depending on how much is read and where the start and stop or the direction. Our DNA can be read both forwards and backwards. And it's an incredible density of information stored in our DNA. And that's just what we know. Okay? And we can observe that the genomes have this long sequence that's preserved through generations. Modern engineering actually has tried to synthesize DNA for the storage of data for computer purposes. It has not been incredibly successful, but the amount of information you can get into a 4-character code is actually staggering. Remember, computer works on 2, 0 and 1. So what that proves is how perfectly designed that system is. They can't put this DNA into your body and it be functional. That's not what it's about. Go.
When did DNA start? When did we first start seeing DNA? And figuring out-
Watson and Crick kind of simultaneously discovered or hypothesized that it was a double helix. We knew that there was something in the cell, and I don't remember the exact date. It's 70s? 69? Okay. 1860? No, Francis Crick and Watson are no. He
Initial identification.
yeah,
Double helix is 1953.
1953. But I know it's Watson and Crick,
Watson and Crick.
and so it's been
Double helix.
in our lifetime of many of you sitting here, right? And our real understanding of it is still very dynamic. They used to only understand a very small fraction of the DNA. The Genome Project, I think, was the 90s. And what they discovered is the more they looked, the more function they found, which is complicated for an atheist model. All right, so DNA encryption is the wrong word. So they're going to start attacking our definitions and the way we use DNA. And they'll say, encoding represents information. Okay, they'll accept that. But encryption infers secrecy. I thought Pete was going to hit me on that one earlier. Encryption just means restricted access. That's how we defined it. Don't let them redefine it just to attack your word. That would be what I would say. We know regulated access is what we're talking about. The fact our DNA cannot just be randomly accessed. It takes very specific proteins assembled in a very specific way. They're actually called molecular machines, nanomachines, inside each one of our cells in order to duplicate and build proteins. It's much more complex than DNA going to RNA through a ribosome to a protein. It's very, very complex.
I did have a question, I think.
Sorry.
Earlier you made a statement that kind of landed flat. I found it real amazing, remarkable. You said membranes have no DNA to them?
There is no DNA that builds a membrane.
Okay, no DNA that builds a membrane, but what is in a membrane?
A membrane doesn't have DNA either. It's just proteins, right? It's a bilayer lipid form. But what's interesting about the bilayer lipid is actually there's more holes in that than there is bilayer lipid. All these special machines that let things in and out make up more of the membrane than the membrane material itself.
And that's every cell, no matter
Every
the
single
type of
cell. Yet they've never been able to determine any DNA that is building a membrane. A membrane is just a duplication of the previous cell. It actually is a major challenge to the evolutionary model, but it's just where the science currently is. Okay. Compression is a mixed analogy. They don't like the fact we talk about compression, that overlaid function. But what I see when I did my research, I looked at all the different articles that were out there. I couldn't find them. They're all still making these claims. And the one in the middle is genomes contain redundancy, repeats, and non-coding regions. This is a claim. You'll find it in books. You'll find it in articles even today, and it's not true. It's not true at all. In fact, it's not scientific at all. The science, the ones that are involved in genetics, would disagree with the very argument that most atheists use against the creationist concept of DNA. We cannot find, actually most of the so-called non-coding regions of DNA we've now discovered are the regulatory portions that determine when certain sequences are turned on and turned off. That information is also in our DNA. It was always a mystery, but they began to see that there's bits and pieces. Sometimes they'll talk about junk DNA. Well, it's only junk because you haven't figured out what it does yet. No one has been able to prove there's any such thing as junk DNA. So these arguments, and when you push somebody in a corner, they're always going to come to arguments that are untrue. When we talk about life and the origins of life, you'll see a lot of these that have totally been disproved. But if I grabbed a biology, I know Alita's not in here today, but if I grabbed her biology textbook from Fort Bend, I guarantee every example that has been disproven that we'll talk about in a couple of weeks is probably in that textbook.
So
Okay.
you're saying that language doesn't have redundancy? There's a
Well,
lot of languages that, like Spanish is one where you'll have double negatives, right?
Yeah.
In order to like emphasize the negative statement that you're saying. So that's kind of weird that they would say that redundancy means that it's not a language.
well, what they're doing is they're trying to attack one part of our argument, and they don't realize that there's a ripple effect to something else they take for granted. And that's something we always, if we're smart enough, I wouldn't be smart enough to maybe come up with that, but if they're challenging one part of our argument, we need to think about where it actually ripples to and how does it tear apart something they take as foundational. But he's right. These arguments don't disprove design in any way, actually. If it was true, it still wouldn't disprove design. But in fact, it's not true. It's not true. So error correcting and repair. This is one of the most amazing things about our DNA is it seems to be able to detect when there's mutations, because there's millions and millions of mutations happen inside our body, every day. And our DNA has built-in systems to repair most of those. And if our DNA is too damaged, our body has self-destruct mechanisms and kill the cell. I mean, we get sick and we hear about all these diseases, but that's such a small fraction of the things that go wrong in our body every day that our body deals with naturally. The repair mechanism, the correction mechanism in our bodies is quite remarkable. And again, that is coded from the DNA. That sound weird?
Can we control our DNA
We can't.
by what we eat, by what we do?
No, DNA is a code that we're born with. It can degrade over time, obviously. You can get a disease. You'll hear about people wanting to do genetic modifications, and you'll hear gene splicing. It's a little complicated.
Like
Because
cancer's a degradation of your body's ability to read that DNA properly. Whenever it's trying to rebuild its cells, so it'll either like build too many cells, or it just won't build them at all within that particular area.
yeah, and it's usually confined to a certain organ, which
But that's like stem cells is like one of the things that they try to use as an argument for, you can inject stem cells into a particular area and it copies the DNA of the surrounding area, right? Which is kind of what, you remember Christopher Reeves? Whenever he was real big on the stem cells injections in order to help out paraplegics. So you take the stem cells, put them into that spine, and it would replicate the cells that were around it.
Quest Diagnostics.
There's some stem cells that can cure disease, so it's like blood, like leukemia and stuff like that. But majority of them don't work.
yeah, generally needs to be your stem cells to really be effective.
They
That's
tried to inject it to the heart and it didn't work.
so a couple more. I'm trying to get out of here. They're going to attack our language analogy, right, that we talked about earlier. I think we shouldn't call it a language. It's a code. I think we should say it's just an analogy. We're saying our DNA code is similar to language. We're not claiming it is language, okay? It's a characteristic that's very similar to language. This is a common argument against the theist concept of DNA. So you're talking about it being a language. Who can read it? It's like, well, my cells can just fine. But again, a mind is required to functionally process a language. So they're right. Just accept that I'm just using it as an analogy. It's no big deal. So let me skip just a little bit. So they're going to have a lot of arguments against our view that DNA comes from a mind, right? They'll say evolution explains DNA. Well, that's disputed, right? The origins of information system seems to be a deeper question because we have never observed an information system spontaneously coming into existence. We can only observe ones that already exist. So evolution is not an explanation. It's just a guess, right? That it can't be God, so evolution cures that problem, right? It doesn't. Information arises naturally. And Pete was right. Yes, but we're not really talking about just information. We're talking about specific function.
No, my point is that these patterns, right, we see them everywhere. You know what I mean? And we're naturally coded to it. So if we can recognize one pattern, it makes us actually better at understanding and predicting another pattern.
It does.
Right? That's like part of, whenever we go to school, we learn about multiple subjects, the liberal education. It makes us better at being able to learn other subjects.
That's
If I
how we.
learn Latin, I'm better at learning Spanish, German, even languages that aren't related, simply because these patterns are repeated, even like across cultures. Right?
And it's kind of like science is the same way.
Yeah.
We discover the laws, and then we apply the process that we learned in discovering those laws to discover other laws that mirror what the universe and how it behaves.
Whereas if it's just chaos, why would all these things be connected? That was the whole point behind Aristotle in academia, right? Why Aristotle himself was saying that he believed that there was a greater being, a logos, right? That everything had to be brought to us. Is that there's something that all of this order originally comes from.
Yeah.
Right? And we can kind of trace it back by comparing all of these different things. In his case, he took these different sciences and had everybody just discuss them. He's like, hey, let's get a sailor and a gardener and have them discuss things and see where these commonalities
See where the commonalities are. And I think that's important. Now, this is probably one of the strongest arguments they'll use against the deist or the Christian or the theist. Bad design should disprove God. Use it in morality, they'll use it in science. But imperfection are better seen as a degradation of a perfect creation than a disproving. I mean, evolution doesn't make sense to have worse and worse design in evolution, because then it would de-evolute, right? It's not evolution. We see a lot of de-evolution in our world. We don't see a lot of evolution. And then God of the gaps, I think, be kind, but it's an argument of ignorance. It really is. You say it's God of the gaps. Give me an explanation. A mystery is not an explanation. It's willful ignorance. And sometimes we have to call it out for what it is. So, again, deity information belongs in our cumulative case for a creator. I don't think there's any doubt of that. It's strong, but by itself, none of the things we talked about today would prove God. There's definitely no evidence that disproves a creator. It's okay. What do you guys think about information?
Heavy.
Yeah, heavy. So as we close down, I'm going to play a video. You guys can go ahead and leave if you want. I want to introduce, the kids know this group. Stephen Meyer, Discovery Institute, put together a bunch of these little animated shorts about origins of life. This one's about information. Just introduce it to you, and then you guys can find it on your own. Long story short.
Think about some of the coolest designed things. Cell phones, rocket ships. When we look at them, we find layer upon layer of complexity. Things specifically designed to carry out a task. Millions of lines of code or engineering in order to do what they do. The more we understand about how these apps or spaceships work, the more impressed we can be at the sheer amount of information needed to create all these parts and get them working together to perform a function. Even if we had never seen a rocket ship before, we would know that it was designed by someone. As complex as all of these things are, they pale in comparison to this.
The single-cell bacterium.
And that pales in comparison to your handsome or beautiful self. Look at you. So amazing. Why are you and this little bacterium so amazing? Glad you asked. Running your cell phone and these spaceships are thousands of lines of code, as well as the hardware that makes them do their thing. Inside of you, and this little bacterium, is the same thing, but more advanced. There is a digital code being interpreted or read by computer-like information processing hardware happening inside of you. A world of factories upon factories, building micromolecular machines that cause your hair to grow, make blood, muscles, energy production, waste disposal, manufacturing new miniature robots, programmed to make you do the things that let you live. A tiny little metropolis, and what's running all of it is information. But what is information? The reduction of uncertainty. That's not super helpful, I get it. Imagine you had a dog that was asleep. Oh, what a good boy. But shh, he's sleeping. You don't know what he might want. You're uncertain. He's not providing much information. But if he woke up and started barking at the door, maybe he wants to go outside. Maybe it's the UPS guy. He's eliminating some uncertainty. But if he stood up and said, "It is Tuesday. I would like to eat some tacos," that'd be a lot of information. Language is very good at communicating information. Another way to think about it is this. Information is a message or instructions with meaning. Inside of you is just such a language, and heaps of information, not just in your brain, but in every cell of your body. Each cell has a gooey core called the nucleus. Inside the nucleus are chromosomes, tiny little spools that hold wound up pieces of your DNA. Inside your DNA is your genome, which contains your genes, segments of DNA. Those contain the information needed to make proteins, the machinery of life. Really important, by the way. DNA contains coded instructions and programmed commands that are read, interpreted, and carried out automatically by the cellular machinery in your body, just like computer code. With software, the instructions come in the form of letters and punctuation that are arranged to encode computer commands. In DNA, the instructions come in the form of the nucleotide bases, A, T, C, and G, that are arranged to encode biological commands, amino acids, and other instructions as well. There are programmed instructions in DNA just like in computer code and software. Some of the world's smartest, most eggiest of eggheads agree that DNA is like a computer program, but far, far more advanced than any software ever created. The machine code of the genes is uncannily computer-like. DNA is something like the hard drive on your computer, containing programming. Life is a DNA software system containing digital information or digital code. From Bill Gates to Richard Dawkins, Francis Collins, and Craig Venter, they all agree DNA is a code. This is absolutely amazing because we know that digital computer code and software systems don't write themselves. Advanced programmed technology only comes from one source: intelligence. Of course, some people claim that the DNA code is an exception. They say it could have developed without intelligence. Random mutations or errors could somehow add up over time and create the software code that runs life. Well, think about any software you know. Is a random change going to improve things? Or will it tend to break things? If you change computer code, sometimes even the slightest change, it'll break. Change DNA and, sorry to say it, you don't get superpowers. You'll get cancers or other horrific diseases or even death. Random changes are about as likely to produce functional software code, or DNA code, as random typing will make an intelligible novel, or paragraph, or even a single sentence. Whoa. Mutations and errors break DNA. Fortunately for us, our DNA code is more advanced than regular old computer code. It has special features designed right into it to automatically minimize potentially dangerous mutations. Remember, the DNA code works because of how the nucleotide bases are ordered. How they're arranged determines the things that they make. And they're read by cellular machinery not one at a time, but 3 at a time in a group called a codon. Some codons will build one of the 20 different amino acids, which are the building blocks of proteins. Other codons act as signals to start or stop the process of reading a gene. It's a very finely tuned process with multiple redundant safeguards, because one amino acid can be coded by multiple different similar codons. This brilliantly minimizes the detrimental effects of mutations on the DNA code. Sort of like how some words still mean the same thing even if a single letter is different, like color, or gray, or advisor. Basically, the British spell words wrong all the time, but we still know what they mean, usually. In English, only a few words are like this, but with DNA, it's like this for every combination of letters. In other words, the genetic code is specifically set up to minimize the effects of mutations. Like one of those toys you can't knock over, the genetic code is designed to be quite hard to keep down. Here's how it works. Say you need some of the amino acid building block leucine in your life. Your DNA could code for that with a codon CTA. But what if a little error snuck in? A little rogue particle knocked your DNA around, changing it to CTT. Oh no, surely now you're gonna know. Oh no, that still makes leucine. You're totally fine. Well, what if another radioactive particle came in, smacked your DNA around some more and changed it to CTC, or CTG, or even TTG? No worries, bud. Like I said, your DNA is exquisitely designed to resist mutations that change the amino acid. Even mutating TTG further to TTA would still make leucine. Your body would still be happily humming along, subscribing to this YouTube channel, liking this video, even with all of that nonsense happening inside of you. Information and code are running the show in biology. Your body is amazing. But would you believe it if I told you it gets even more amazing than that? Good. Good. Because it does. We're only scratching the surface of how impressive, how packed with information your genetic code is. For each codon, set of 3 letters, there isn't just one way for it to be decoded. There are 6 possible ways. And organisms like viruses and even bacteria can make use of all 6 open reading frames. The genes actually overlap one another, not only incredible amounts of information, but information compression. This doesn't happen by chance. Maybe you've heard of palindromes, words that have the same spelling forward and backward, like race car, tennis, kayak. It's a neat trick, but not quite information compression. You're not packing more information into the same amount of space, it's just redundant information. But what if you had words that spelled one thing forward and a different thing backwards? A heteropalindrome. That would be special. These words do exist, and they are very rare. It's even more rare to have an intelligible sentence using heteropalindromes. Let's try to make one. It is highly unlikely to evolve an overlapping gene by chance. You end up with gibberish. This problem is actually quite similar to biology. Just as the vast majority of random combinations of letters will not give you a meaningful sentence, and even fewer will give you a working sentence forward and backwards, when trying to build something in biology, like a typical enzyme, the vast majority of possible combinations of DNA letters won't work, even reading them forward. If you had the additional requirement of needing to be read not just backwards, but multiple different ways, let's just say the odds don't get any better. This heteropalindromic information in DNA is an astonishing form of information compression that strongly suggests intelligent design. Researchers have shown that the genetic code doesn't just allow this kind of information compression, but it's actually optimized to allow overlapping genes to exist. We have a universe of language, digital code inside of our bodies that is read and processed through complex nanomachines. These work together in a beautiful choreography of mind-boggling complexity to create even more machines. Where in your experience do things like language, proofreading, nanomachines, and information-rich code come from? You know the answer. They have only one known cause: intelligence. Books have authors, machines have inventors, code has coders. Therefore, if we want to understand biology, our own bodies, how and why diseases work, if we want to advance science, we need to view it from a standpoint of intelligent design. Scientists who saw DNA as a product of intelligent design predicted many of these things, new layers of information in our DNA, particularly where other models failed. But more on that in the next video. Thanks for watching.
If you can get to YouTube, it's called Long Story Short. They have a lot of them. I think they have 14 or 15 videos that walk through different issues with the origins of life and explain it. Their DNA one is just the one I showed you. But long story short, it's Discovery Science, I think, is the group that puts on. Stephen Meyer, if you're, I think, is the kind of the head of that group. He's been involved with them, but he's not part of their organization. This is not kiddie stuff. These are very nice cartoons. They look like they're going to be children's videos, but it's really for us adults. I appreciate the pictorial to demonstrate it. So I just want to introduce you to these guys. I like them. We've been showing them to the kids on Wednesdays here and then talking about them. Remember some of these last fall? All right. All right, I will let you guys get out of here. Yeah. Do you want to pray us out, Carolyn?
Gracious Lord, we praise you and thank you for today. We thank you for the group that came tonight. We thank you for each home represented. We thank you, Father, for opening our minds and our hearts to you to learn more about how to answer when people attack us. Thank you, Lord. In Jesus' name. Amen.